Today we're going to learn about what scientific notation is and how we record numbers in scientific notation. So let's begin. Now in front of me I have two numbers here that are representing scientific notation. For a number to be representing scientific notation, the first part of the number, which can be found here or here, has to be greater than 1 or less than 10. It can also be equal to 1. But then it's multiplied by 10 to a power. Now in the first problem you can see that that power is a positive number, and the second problem you can see that power is a negative number. But let's take a look at expanding each one of these numbers to see what they represent. So in our first number we've got 4.35 multiplied by 10 to the power of 6. Now if we were to expand this out, what this is actually saying is it's 4.35 times 10 6 times. But we know every time we multiply by 10, we essentially move this decimal place one spot to the right. So if we're multiplying by 10 6 times, what we need to do is move this decimal place 6 times to the right. 4, 5 and 6. And we need to fill in the zeros anywhere that there's a gap between where we move the decimal place. So when we multiply 4.35 by 10 to the power of 6, the number equals 4,350,000. So let's try with the number on the right. Here we've got 1.78 times 10 to the power of negative 6. Now if we were to expand this out, this is the same as saying 1.78 times 1 over 10 to the power of positive 6. Now to multiply fractions, we've got to represent the 1.78 as a fraction, and we multiply the numerators and the denominators together. So this essentially equals 1.78 over 10 to the power of 6. But we know that 10 to the power of 6 is essentially 10 times 10 6 times. And the 1.78 is still at the top. So what we're saying is it's 1.78 divided by 10 6 times. And every time we divide by 10, we're essentially moving the decimal place one spot to the left. So if we start with our number 1.78, we're essentially saying that we need to move the decimal spot 6 spots to the left. 4, 5, 6. And we put the zeros everywhere that there was a gap. And the decimal place lives here, and I like to put a little extra 0 at the front. So we're essentially saying this is equal to 0.0000178. So what we can see here is scientific notation can be used to represent a larger number when it has a positive power, or a smaller number when it has a negative power. So now we know what scientific notation is, let's have a look at why we might use it. Now in front of me I've got the distance between the Earth and the Sun, and we can immediately see that is a really large number. So this is where recording a number in scientific notation can come in useful. So to record a number in scientific notation, there's a series of steps that we need to follow. The first step is we need to put the decimal place after the first non-zero digit. Now the first non-zero digit is this 1 right in the start of this problem. So we're going to be putting our decimal place right here. So now we write the number down. So this is equal to 1 decimal place, and we continue recording all the digits including zeros until there's only zeros remaining. So in this case I record the 4, the 9, the 6, but after the 6 there's only zeros remaining, so I stop recording the number there. I then multiply by 10 to a power, but we now need to work out what that power needs to be. So to do this, we work out how many times we moved the decimal place. The decimal place started here, and we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times to get it between the 1 and the 4. So our power is going to be 11. But the final step is we need to work out whether it's a positive power or a negative power. Now in this problem we're representing a larger number, so our power must be positive. Now we can check to make sure that we've got the answer right by expanding it back out. Now we know that this is going to be 1.496 times 10 to the power of 11. So we're going to be moving the decimal place 11 spots to the right. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'll go in there. We need to put the zeros wherever there's a gap. And then we record our number down. One more thing that's really important to include when you're recording things in scientific notation is the units it's measured in. Now in this case it's measured in meters, so I need to record the units here. So as you can see here, that really large number has been written in a much smaller form. So let's have a look at what happens when we've got a really small number, such as the mass of a dust particle. Well, if we follow our steps, we first put the decimal after the first non-zero digit. Now in this case, we've got all these zeros at the front. So the first non-zero digit is going to be this 7. So we put the decimal place after the 7. Then we record the number, so this is equal to 7, with all the digits, including zeros, until there's nothing but zeros remaining. So in this case, it's going to be 7.53, and we multiply that with 10 to a power. Now to work out the power, we need to work out how many times the decimal place moved. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So our power is going to be 10. Now the final step is to work out whether we should be using a positive power or a negative power. Now this is a smaller number, so we are going to be using a negative power. So it should be to the power of negative 10. And then finally we need to record our units, which is kilograms. So let's revise what we've learnt about scientific notation. A number is in scientific notation if it is written as a product of a number, which we've represented as A here, and a power of 10, where A is a number greater than or equal to 1, but it has to be less than 10. For example, if we've got A times 10 to the power of B, A has to be equal to or greater than 1, but it has to be less than 10. Where B, the power, has to be a whole number or an integer. Some other things that we learnt is that if B is a positive number, then it's representing a larger number, and when we expand it, we move the decimal place to the right. However, if B is negative, then it's representing a smaller number, and when we expand it, we need to move the decimal place back to the left. So now I'd like for you to have a go. In front of me, I've got two numbers here that are represented in scientific notation that I would like you to expand back out to the whole number. And then I've got four other numbers here that I'd like you to reduce back into scientific notation.